This is CSE 541 Robotics, Phase 3 of my Rubik's Cube solving robot. The purpose of this phase was to implement Herbert Kociemba's two-phase algorithm and take his solution that's returned from the algorithm and translate that to the NXT hardware. I'm using the checkerboard pattern as a proof of concept for a short video, and notice I've already scanned in the color map as part of Phase 2. One new thing you'll note is that I've produced two-phase notation and sing-master notation from this color map. Given the fact that the center pieces, or the center colors never change, you can associate those to faces and therefore denote notation on where each color is according to what face. So therefore, Herbert Kociemba's algorithm implements two-phase requires two-phase notation as input and provides a solution as a series of face turns as output. So without further ado, I'll demonstrate Phase 3. So let's go ahead and run LabVIEW. LabVIEW is the primary means of communication with the NXT bricks. I'm using two NXT bricks with five motors acting as servers with PI control, PID control, and notice the solution already is generated or was produced, and in a matter of seconds the robot has already started to solve the cube. Now there's only 6 face turns. It's already completed 2 of them. So I had a little had to do a little work there to get that going, but it figured it out, so that's good. I'm using PID control plus an acceleration offset once it reaches a smaller angle to help it home in, because it uses the error to for the PID control, and when the error is small, the voltage sent to the motor to rotate, it's a low amount of power, it doesn't respond very well to the last little turn that it needs, so you get a nice turn when you add an offset to that. So it has 2 more moves left. I also keep track of the seconds. It's been 1 minute and 30 so far. Okay. It's now working on the last turn, back to 2. Now, one constraint with this design is that it can only turn one face at a time, so it has to orient the face to the bottom, rotate, and then reorient back, a similarity transform. So notice the cube's already solved, so it just had to reorient back to the top face, or the upper face. And there you have a solved cube. Phase 3 complete.